Whew, hey everybody, this is Larry. This is day 25th of February. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problems. Shortest unsorted continuous subarray. Let me know what you think about this problem. And also, I solved these live, so if it's a little bit slow, just fast forward, do whatever you need. Okay, so this problem, given an array nums, find one continuous subarray that if you sort then the whole array resort. What does that mean? Oh, so basically, you have to sort this subarray, and everything is sorted, right? Well, and then you have to do the shortest. Okay, I mean, I guess these examples are not supposed to help you give it away. Can you do an O of n? Huh? Yeah, I mean, I'm trying to think. I mean, so the ideas that I'm thinking in my head right now is some sort of idea around prefix sum and suffix sum. You may think that I don't think greedy works, or I mean, maybe it is greedy, but at least not the way that I'm thinking about it. We're like, okay, if you just take the longest beginning subsequence, and then you have some junk, and then you have some numbers at the end, right? Like this is not good enough, or like 1 to 5 is not good enough because you need to put the 244 in the back or something, right? So I think and I think the crappy thing, to be honest, is that the follow-up question kind of gives it a little bit of a hint. I mean, definitely, obviously, you can do it in different ways. And yeah, if you just sort the array, you can do this in very quick time. And so I didn't speak about that because I think I just jumped ahead in my thought process. But yeah, if you just sort it and then you kind of go see where it differs, then it should be obvious where the first place that differs and the last place it differs, right? So basically, yeah, you just take this, you take the sorted number, which is like a sorted list, which is I guess some variation of something like this, right? And then you just take, okay, well, this is the first place it is not the same, and then you do the same thing for the suffix, which in this case there isn't, but let's say there's 255 255, then this is this, and you just take the middle, and you just take the index, right? So this is n log n, obviously, and it's pretty straightforward, or of n extra space, stuff like that. But because of the follow-up, I already kind of jumped ahead and try to figure out how to do it O of n times. And my idea is some sort of prefix thing, though it might come out that looks like it's just greedy. I mean, yeah, they're kind of related, but the idea is okay, right? Well, the first place where it's inverted is that true? It's the first place where it is inverted enough, so maybe it is that greedy in that way, because and also if you do the same by symmetry, you could do it to the end. But no, because in this case, this is not true, right? Because this is also the first place where if you go from the back up, this has the end, and you have to put the 24, all the way up. But maybe that is just. I'm thinking about like something similar to bubble sort, but no. I don't think that's quite right, because you can imagine there's a number that's like this is 3, and you know that this 3 wants to be here somewhere, but just because this is the first place and inverted, you have to actually go all the way back, right? How do I do this in linear time? And my eyes are very tired and heavy and all that stuff, so maybe this is a kind of not a great day for me to work on a thinking problem. Let's see. So in this scenario, so how I usually attack these things is just try to think about how to think of a greedy way of getting, for example, this 3 up here, but also in the same time think about counter cases for my greedy. So so how would I look at this? Do I need one time? Can I do a stack? Because why would I say a stack, right? That means that when you have an increasing list, you have a 3, so then it would go pop, 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 and then now we know the 3 has to go here, and then we go, and then basically we just keep on running it until everything is popped, right? Or that we know that nothing after that is good. It's gonna be small enough. I think that actually works. So I mean, obviously you also have to do it from the back. I think I was trying too hard to do an all one space without being explicit about it. But using a stack, the idea is that, and this is actually turns out to be a monostack, which, as I always say, usually comes up as a coincidence rather than something you're like, oh, this may be a monostack. Let me use that monostack, because it's an abstract data types. So if you ask yourself the right questions, it does come up. And the question here is that for each number, what is the the smallest number to the what is the first number that is equal to or smallest? I don't know if this is supposed to be unique, but I guess it's what's the first number that's supposed to be to the left, right? And in this case, it's a variation of the monostack, because you only push to a stack from the beginning, and as soon as you get one here, like even for the 3, you will not append it to the stack because it doesn't make sense otherwise. Though I guess you could put it on, but it wouldn't change the results. You just need the prefix anyway, right? Because once you have to index this to be 6 or whatever, then it's good. Yeah. So the question. So I would also say the caveat is that if I was working on it on a contest, I would have already probably finished typing it. But I'm just trying to go over my thoughts on how to prove this a little bit, which is that for each number, we want to get the smallest number, or we want to get any number that is we want to get rid of any number that's larger than this number, right? So you could kind of think of it this way. So now let's say we have a prefix of this. Let's actually kind of invert the order a little bit. Let's do 8, 4, 3, right? Just for fun. Here we go. Okay, where do we want to insert the 8 in a sorted list, right? Well, we want to insert the 8 here, and that means that by definition, we the 244 is no longer qualified to be part of that, and obviously 8 neither, because that's already after the prefix. And then same thing for 4. 4 we inserted here, I guess, and that would already eliminate these 2 numbers, and so forth. So that's the idea, and that's what I mean by trying to get, and you kind of pop it off one at a time. You could kind of, and is the implementation, but you can think about it as, okay, I want to have this number. Where do I insert it to make it sorted, right? And I think now I have sufficient enough to do the coding. I didn't skip this. Oh, I skipped the suffix part because you can prove that by symmetry, right? You could just do it backwards. So let's do that. And yeah. I'm trying to think whether there's a case where the prefix and the suffix overlaps without being, I mean, there's one obvious case where they overlap, which is that if you use this entire string, which we could just check, I suppose. And then if that's not the case, then can they still overlap? And I think the answer is no, because if the prefix is such that there's a number that is smaller than it, or a number that's larger than that's before, by definition in reverse, that number is also goes after that number or the other number, right? I didn't explain it that well, but to draw an example of what I'm thinking about is, okay, you have 1, 2, 3, let's say 8, 7, 6, 9, 10, 11, right? Oops. 9, 10, 11. 6 will cancel out these 2, as we said, but also by definition, then 8 will cancel out these 2. So I think that's what I'm saying, so that we don't have any weird edge cases where they overlap unless it's the entire string. So, okay. So let's finally get it started. I know that I talk a lot and try to figure out and try to explain all the edge cases as I can. To be honest, like I said, if this was a contest, I would have first I would code it first and then play around with the code to see if I could get it. But I would have done it more maybe in parallel. But yeah, let's get started. Let's put stack as you go. Oops. For x is in nums, stack dot append x maybe, and then let's reset that maybe a variable called pop is equal to force. Okay. Oops. If length of stack is equal to 0, or okay, I guess we just append this, and maybe we can just put this here then. Fine, and then we start from the first. Okay, so then now we go if stack of -1, would there always be a number? I don't know. With length, okay, I think we can just check. Okay, if length of stack is equal to 0, we return, or we don't return, we break, I guess. Otherwise, because that means that somehow we removed all the numbers, but I don't think that's possible unless all the numbers are removed and then you break anyway, right? Okay, otherwise, while length of stack is greater than 0 and the top of the stack is greater than x, we do stack.pop. Yeah, and then also this is popped is equal to true. That means that we remove characters before. That means as soon as we remove one character, we no longer push, right? So if not popped, we append the stack. And then now we can get the length of the stack is the number of characters in the prefix. So let's do if length of stack is equal to the length of nums, then we either we have the entire stack, so I don't know if we return 0. Okay, so we return 0. Oops. Otherwise, we get the suffix. But before that, I'm going to return 1000 so that we can kind of test these test cases real quick. Because if this is wrong, then why bother? Well, not, I mean, this is not going to be right, but you can at least make sure that is wrong in a consistent way. Otherwise, why bother, right? Okay, so the zeros are correct. That's what I was looking for. The 1000 is a little bit awkward, but maybe we could have just returned the length of the stack. Someone follow me right now. That's a little bit awkward. But am I streaming now? I mean, I am recording, but I'm not streaming. But anyway, so yeah, so the prefix is 1 in this case, which is what we expect. So yeah, so the prefix index is equal to the length of the thing. Well, it's not even a prefix index, just prefix length, right? And then now we have to do it for suffix, and of course we can. Now would have been a good time to write this in a way that is, in a modular way. So you could do a copy and paste, but I'm going to do it in a modular way. Though it's going to be a little bit funky. So yeah, get prefix of nums, right? And then we return length of stack, and then now we can do prefix length is equal to get prefix of nums. If prefix length is equal to length of nums, we return 0. Otherwise, we do it for the suffix. So suffix length is equal to the get prefix of the same thing, except for two things to know, right? One is we get the greater one. So one thing is that we're gonna have to make it bigger. So we can do something like x for negative x for x in nums to kind of invert the direction so that it, this makes it instead of it inverts the sign here from greater to less than. Maybe I think to be honest. If you want to do cleaner code, you actually would maybe do you maybe pass in like a comparison operator and then do the comparison here. I'm a little bit lazy and it's like 3:40 a.m. here in New York. So this is what I'm going to do. If you don't understand it, leave me in the comments. But basically this just inverts the sign for the greater than. And now we have to get the suffix. So I'm just going to just invert this way. So yeah. So basically we return length of nums minus prefix length minus suffix length. I think that's okay. Maybe I'm off by 1, but let's give it a go. Ooh, our generator, fine. Let's make this a list. I think that's what I wanted to do. Cool. Yeah, so let's give, I mean, we could test more, but let's give it a submit. Because I'm a little bit lazy today. Okay. And I mean, I was probably like 80% confident this might be typos or off by 1s, but otherwise, like the code and algorithm, I'm actually reasonably comfortable about it. And I'm just like, again, I need sleep. Sorry, friends. But yeah, so this is my code. We want to snapshot it. But what is the complexity, right? Well, this one, you know, we just have stack and we use stack space. So this is going to be linear time and linear space. The space is just a stack, so yeah. And this turns out, as I said, this turns out to be a mono stack. But note that we never really mention it. And you know, the key thing is just figuring out the invariant. Okay, and of course, this is O of n time and space, and we only call it twice, one for the prefix. Oops, and one for the suffix. So this is going to be overall O of n times and O of n space. Yeah, cool. I'm pretty happy with this solution. I don't maybe we take a look at the solution button, but I don't know. I feel like I'm pretty happy with this solution, to be honest. And this is taking a long time to load because I don't know, technology is hard. But brute force. I didn't even actually look at n. Oh, because the follow-up told me to look at it. Better brute force. Using sorting, that's what I was saying. Using sorting before. Using stack. Okay, cool. Yeah, they copy and paste into the twice. But cool. Let me go back to the solution. But yeah, that's all I have for this one. Hope that was a good explanation. Well, I mean, either way, that's all you get. Hit the like button, hit the subscribe button, join me on Discord, and I hope you have a beautiful day, have a beautiful end of the month, and next month if you don't come back. But yeah, take care of yourself, take care of others, to good health, to good mental health, and I'll see you soon enough. Bye bye.